Hi, I'm James Hartwright from Cognition Studio, part of the Certus Solutions group. Thank you for joining me today. I'm just going to spend about half an hour talking you through building out intelligent assets. And we're not really building intelligent assets, we're building what look like intelligence, artificial intelligence, if you will. The first part here is that this building out is part of a digital transformation program. We're starting from the point where you've got your enterprise asset management system, your Maximo and the like, and you've got more data coming in. So you've got IoT sensors coming in, you've got the SCADA data that you've always had that you want to do more with. We move that up into what we call the single view asset. So bringing that data together and starting to utilize that to improve your asset management process. Then up into, well, bringing it together is great, but giving it to people, surfacing it, giving that information in usable context is that's the system of engagement improvement. And then we mature all the way up into a system of intelligence. So taking all of that information and starting to build analytical models, starting to give AI capability to enable people to ask questions of the data. And it returns something that's strong and contextual. But back to where we are today. Asset maintenance processes is a balancing act. We've been focusing for many years on we don't want failures, we don't need failures. So we've been working on preventative maintenance. This is running the cycles of maintenance according to the schedule that initially the provider has given us, and then through our own experiences revising, usually reducing those maintenance schedules. What we're getting to in a lot of cases, though, are at the point where maintenance is carried out too frequently. And that maintenance process is, we're getting maintenance-induced failures. That's going the wrong way. I'm not saying we want to go back to the reactive performance. Well, many of us, if we're in utilities, can't do reactive performance. I can't have a feeder line going down because there's a whole group of people who will stand up and complain, and I have standards to meet. So, and not just that, but just the safety part of an impeller blade spinning off. That's not a good way to be. But some analyses have gone, well, if we look at that process of preventative maintenance and we start looking at the age of the assets, etc., well, age-related failure is occurring like 1 in 5 times. So we need to find that middle place, and it's probably what all of us are already aiming and trying to do, and that's moving into the predictive, using all the information that we can gather and we now have to hand, and actually saying, okay, this thing's going off kilter, and us looking at that and making the right decision as experienced planners and engineers, through to something that is prescriptive, where effectively the asset's waving its hand and saying, something feels wrong to me based on what you've told me. Can you do something about it? Come and have a look. Tell me that I'm not worrying too much. So in getting to that level of predictive and prescriptive, I've set out that I think there are 4 things, and I'll run through those in turn. So we've got data, visualization, leveraging the knowledge we have, and the good old analytics. So let's start with data. So the first part on the data is bringing that information together with an asset-centric view. Think of so taking a page from retail, where we're customer-centric, we're thinking asset-centric. So think about all the things that go on with the asset, the behaviors, their underlying content, the age of them, and what factors that means, and bring that together. Bring the maintenance history together, bring in where that asset is. Is it near the sea? Well, yeah, we're probably going to get a bit more corrosion than if it's inland. Bring in the weather data, because the weather's going to also impact the age, the reliability of that asset. Bring all of the connections in. I've got upstream and downstream assets to my asset. Each of those will impact the other. We need to think about that. But really all we're doing is capturing it, which we're probably already doing, connecting it together, and making it available to people. Humans are really good at bringing together what seem like uncorrelated data and making sense of it and making good decisions out of the back of it. we do, if we're going to do this, and we should do this, we do actually need to monitor it. We all know that our business processes have changed. The things that we do, the people that are doing it will change. And the systems behind it start providing different data. So when we're setting some of these things up and providing that information to an individual, we've got to start monitoring what it is. We've got to look at the underlying data quality of that data and make sure that if we see something changing, we do something about it. We either tell the individuals, okay, this is changing, you need to do something, or we change our processes of how we bring it together so that they can actually, again, keep on doing the right thing. The second is visualization. The visualization side is, again, probably what we're already doing. So bringing that information together and making it usable. I can grab a terabyte of IoT sensor data and go, there you go, but it only really starts making sense when I've got it in correlation with the other data. So I've got something in where I say, hey, here's the weather over time, here's that IoT sensor data of vibration and internal temperature, so I can now start seeing those anomalies. And I can look at those anomalies and what the asset is telling me before I make the two-hour trip out to site and discover, oh yeah, I should have brought that part along with me. Making sure that when you've got that data together, that you think about how it's going to be used. If the engineer only has an iPhone, a 5-inch screen iPhone, putting a complex graph on that iPhone, it's not going to work, at least if they're like me with tired eyes. They're going to be trying to do that. So you've got to think of it and present it in context to who's using it, how they're using it, and where they're using it. The third one, leveraging the knowledge. We're hearing a lot about engineers. They've been there man and boy, 25, 30 years on the job, and there's just so much inherent knowledge in those brains that we will lose when they retire in 2 or 3 years. So we need to start the process of gathering that knowledge. And you could just go, okay, sit them in a corner for 3 weeks and get them to write down everything they know. Well, that's not going to work. What you need to do it is again, in context with how somebody's going to be using it. So gather all knowledge, get those manuals, get all of that maintenance history, and pull it together. And start turning it into triage processes. We've followed quite a lot what happens in call centers. So the call center system has been set up so that a call comes in, I don't know what that call is to start with. And then you're asking a few questions, you're getting a few little bits of pieces of information, and then you're really following a workflow as a call center operative of ABC, when I've got that done, did I help you today? Yes, thank you very much, goodbye. The processes that we need to set up in this assisting using that knowledge is very similar. Get that expert engineer to think of those processes and think of the missteps along the way. Think of the things that might actually, hey, it feels like this, but oh no, if there's excessive vibration, it's probably more like this. We can build that into something like IBM's Equipment Maintenance Assistant and really, really build that out. And it's not static. It can change over time. We can change that workflow. We can add new things in. We can add new questions, add new information. It's not instant. The natural language understanding, the computer being able to understand us as humans has made some great strides, but it's all been trained on what we ask Google or what we ask Siri. So we need to feed that AI with our knowledge, with our part numbers, that a grommet is the same as a grunion. We need to feed it what's called taxonomies and ontologies so that it can make better sense in context with that thing that we're asking. And you need to do the continuous feedback. So if somebody's used one of those workflows, if somebody's surfaced that information out of the manual and used it, either get them to do the thumbs up, or just go, hey, this was the last thing they looked at. I can get the feedback, and then I can train that AI to go, well, next time you get a question a bit like this, this was the one that the last 3 people chose. So move that up to the top line. The fourth one, analytics. And you know, we think of mostly of analytics, those algorithms, the black boxes that are going on behind the scenes. The starting position for us, though, should also be something that is human understandable, that we as simple humans can see and agree with before we let the black box go off and do something. So a lot of what is happening now in that we've got the SCADA data, the IoT data, we've got the weather data, and we're presenting it on a graph. Well, what we're teaching the analytical process, the AI, to do is to go, right, I'm looking for commonality. I'm looking for things looking the same in little blocks of time. I don't know what they are, but I'm just grouping together if they look similar. And now I just need the human to go, that's all right, that was a hot day, but this looks weird. And now teach the AI, hey, if you see this weird thing happening again, tell me about it. So we start off on that. So our starting process could be this thing finds those anomalies, those behaviors that are weird, and starts telling us about it through a service request or something. Hey, could you go and check this? Because you said last time this happened, I should go and have a look. So you go and have a look. And what you do is, again, that feedback process. So, yeah, that's cool. Thank you for telling me that. But in truth, this wasn't one where I needed to go and do something. And that AI gets trained. It works down to the sort of the minutiae of the data and gets sense of what's good and what's bad. That's the point where you release it to the greater public, where when we get 5 alerts a day, they're good, strong alerts, not the ones where if I got 50 a day, by the end of the week, I'm just going, any email coming in here, put in the deleted mail, please. Yeah, we need to make this workable. We need this not to be imposing. We need to work this within our environment. So let the analytics do in that play. We'll let it work with the human until we go, the black box is brilliant, let it just go. Then into the advanced analytics. Well, a lot of us are now taking images before and after of the processes that we're doing on assets. This is an example we've done with a utility company in Queensland. They were looking at pole tops and saying, okay, I know if my inspector goes and looks at these pole tops, they can say, okay, that one's all right, that one's getting a bit bad, that one's terrible, and you should go and fix that one up now, yeah? Because we're coming into fire season. Oh yeah, unfortunately we are in fire season. We need to sort something about that because it's either going to collapse or if it gets hit, we're doing something's bad. In this AI world, I just need that expert inspector to classify 100 to 200 images and say, this is a SEV 1, this is a SEV 2, 3, 4. We then throw that into the AI. The AI, if a human can spot it, the AI will be able to. If these images of poor quality or too dark and a human can't work out, the AI won't be able to. So you just feed it, train it, and then throw it a load more images. And again, pass that back to the inspector and go, it classified this as a 2. Do you agree? Yes, that's cool. If it doesn't, you just provide it with more images, going, no, actually, that's a SEV 3, not a SEV 2. It will learn off that and get to the point, as we've seen in other AIs, where it actually outperforms the inspectors because it spots things that maybe that inspector wouldn't. I had a bad night last night, got tired eyes, I didn't see what was otherwise patently obvious. When we did that process, for that utility, what we actually found was it was checking back and actually invalidating what we had in our asset management system. So we went, right, we've got these photos. Oh yeah, that's down as a wooden pole. Nah, the image says it's concrete. So, oh yeah, we thought this was a glass insulator. No, it's a ceramic insulator. So all of that sort of stuff in terms of ratifying actually what we've got. So there are 2 things to that. One is we want to do a model for each of those types. So we want to do a model for a concrete pole, we want to do a wooden pole, we want to do a metal pole, because the degradation in each is different. And we can train the AI accordingly. But it was a really interesting one in that through the same image, we could actually map back and look at the as-built versus what's recorded and go, hey, let's go and fix something up. Another example that we're just starting on is looking at vegetation encroachment. Well, the one on the left is quite serious vegetation encroachment, but what we're really looking at here is we've got cameras mounted on trains now. So those trains are running down every month down lengths of track. we can use that video, convert it to images, and start looking at not just, oh yeah, there's a tree in the way, but when I photoed this last month, the vegetation was there, and now this month it's here. And if that growth rate continues, which it will because we're in spring, then it's going to become a problem. What I had with this previous experience was what we tend to do is just send crews down. Okay, every quarter or every 6 months, we'll just send them down this block of line, and they're contracted to chop back. What do? Well, they always chop back, even if it doesn't really need it, because they've been asked to do a job. Well, what we can do now is, we can go, nah, I can tell that vegetation's nowhere near, and based on where we are in the year, it doesn't need chopping back. So we don't even send the crew out there. And on the other side, we send the crew out because we're seeing increased growth in that area and actually doing it. So, the example we had there was there's $1 million per annum spent every year and $15 million spent every year and $1 million extra every year in vegetation management. Well, if we can just chop a little off that, then it's worth that process of trying to work through and get the AI to discover this. So I said there were 4 methods. Well, hopefully, as you've seen, as been talking through the 5th one, there is a 5th one. It's the human. We have to have the human in the loop. We can't just say, okay, there's this black box. I've got really clever data scientists. They will know everything and get them to build it. We've got to keep that human in the loop, because the human is the one that's there looking at the actual physical thing and saying, hey, I'm not sure that's actually what it is. The human is going to train, teach, learn, give alternate options in that maintenance process. So we always have to have the human in the loop. In deploying this, as I said, this is part of a digital transformation. Don't go and do it big bang. You probably don't have the money anyway, but baby steps, because when we have the human in the loop, which we have to have in our asset maintenance process, we're changing their lives, we're changing what they're doing, and people don't like change. So take baby steps, do little iterative things. So build out the capabilities, build out the technology, work with your people, do a day in the life with a maintenance engineer when you're trying to build up these analytics or advanced analytics or the visualization side, and get their feedback and make that part of your deployment program. Building your intelligent assets, 25% about the technology, 75% about the people. If you keep that in mind, you're always going to get a good result. And that's me. Thank you. If you do have any questions, then there's a link that you can use. Actually, yeah, is that true? Sorry, Jamie. Sorry? So shall I just lock out that? Any questions? Yeah? Sorry. Well, it's a double tap, isn't it? Oh, thank you. Ah, cool. All right. Oh, for the local audience then, any questions? All happy? When are you starting? More data, always, as a data guy, yeah, more data is always better. As long as it's still within context, yeah. The people talk about unstructured data. Hey, I've got a photo, and they say that's unstructured. Well, I'm going, well, no, because I know where you took it, when you took it, the image size, what phone it was taken on, all of that sort of information is already great stuff for me.
I think the first step is to understand what data you have.
Yep. Yep. Yeah. And
a lot of data that you have within the organization. It's a matter of categorizing them and utilizing them.
Yeah, and the other thing, I mean, we talk about single view of asset. I don't believe that's true. You have a different view of that data and a different view of assets and how they fit together to you. And if we just go, no, this is the only view, we're failing. Yeah, that thing of an asset-centric thing and the stuff around it, that's what you need. You're building connections between the pieces of data, and if you do that from the start, you can put any lens on that data to how people want to use it. Cool. Thank you.